In this video, we're going to go over now an introduction to integral calculus, getting to understand how to integrate different functions. And so now, I'm going to start by mentioning how to integrate trig functions. So here I've got a quadrant system. On the x-axis here, I'm going to put positive sign, and I'm going to put negative sign on the negative x. I'm going to put positive cos on the positive y, negative cos there. Now, when we are moving in the clockwise direction, this is going to mean we are integrating these functions. So when we get to integrate cosine, we are going to get sine. If we integrate sine, we get negative cosine, just like that. So this is what we use, and that is what we are going to follow. Another rule that we need to know is that when we have the integral of ax plus b to the power n, this is going to give us, so just get the power which is there, we're going to add a 1, so that is going to be n plus 1, and then we're going to divide by the same n plus 1, but we're going to multiply by this a which is here, and then we're just going to add the constant of integration because this is an indefinite integral. Unless if it has got limits, then we don't add the constant c because it is definite. Now, apart from us being able to do this, we also need to understand how to find the integral of, let's say, exponential functions, e to the power x. So this one, for us to find the integral for this one, what we do is, let me not use x, let me use something that is more general, e to the power u. So to find the integral for this one with respect to u, are going to get just the u itself. We find its differential. So we differentiate u and then divide. Now I'm supposed to write this one much better. So I want to differentiate e to the power u with respect to u. First, we'll just get the e to the power u itself. So this function, just get it the same way it is. And then now differentiate by the derivative of u. And then we're going to add the constant of integration. So these are what we're going to use to work out in this practice. And so let's start. If we want to find the integral of 5x to the power 4 plus, let's say, 2x to the power 1 over 2 plus 1 with respect to x, how are we able to do this one? Well, this is simply going to be equal to 5x. We are going to add a 1 to this one, that will give us power 5, and then the same power 5 also divide by it, and then we'll go to the next one. We're going to have 2x. We are going to add a 1 to 1 over 2, that is going to give us 3 over 2, and then divide by the same power which we've gotten, 3 over 2. Now we know if we've got a constant like 1, it means x is raised to the power 0. So if we add x to the power 0 plus 1, so if we add the 1 there, that is going to give us 1x, which we can just say x, and then over the same power that we have, which is a 1 now, and then we are going to add the constant of integration. So basically this we've integrated, and what remains is just to simplify. So this is going to cancel, that is going to be x to the power 5, and plus this will be 4 over 3 x to the power 3 over 2. If we get to divide 2 divided by 3 over 2, this changes into 2 times 2 over 3. That is why we have got 4 over 3. And then we have x, and then we have got c. So that is how we get the integral. So that is it for this one. Let's get to look at another one. We see how we are able to work it out. What if we are talking about the integral of, let's say, 4 over x squared plus 1 over, let's say, 15, and then we have got x on top, and then plus a 3 with respect to x. How can we work out this one? Well, this is the same as the integral. What I want is to not have a denominator which is x, so I'm going to take the x on top. It becomes negative 2, and then plus we've got 1 over 15 x, and then plus a 3 dx. And this is going to be the same as, so to this power I'm going to add a 1. So this is going to be 4x. Negative 2 plus 1, that will be a negative 1. The same power that results, we divide by. And then plus 1 over 15. And then we have got x to the, so this is raised to the power 1, of course, even if you can't see it. So 1 plus 1, it becomes power 2. Same power 2, I divide by that. And then plus 3. 3 is the same as 3x power 0. So integrating that, x appears. And then plus c, which is the constant of integration. So this will simply give us negative 4 because of the negative which is down. Now the x on top is negative, so I can take it down. And then plus, we are going to have x squared divided by 15 is multiplying with the 2 down there, that is going to be a 30, and then plus the 3x plus c. So that is going to be the integral for this one. Let's look at another one. What if we are talking about the integral 4 sine of x minus 5 cosine of x plus 3 sec squared x dx? How are you able to work out this one? Now, already mentioned this when we have got sin here. The integral for sin gives us negative cosine. Okay, so that is what we already mentioned. Therefore, to integrate this one, we have got a 4. If we integrate sin, that we are going to get negative cosine of x. And then we have got a negative 5. If we differentiate, I'm talking of the differentiating very much. It is if we integrate, integrate cos, that is going to give us sine. And then now from our derivatives, we know that if we find the derivative of tan x, this gives us sec squared x. Okay, that is what we know. Now let me multiply both sides by the dx so that I cancel out the dx in the denominator. So that is going to give us d of tan x being equal to sec squared x and then dx, because I've multiplied with dx on both sides. Now at this point, if I get to integrate like this, this is going to give us this, and the integral goes, so that is going to be tan x is equal to the integral of sec squared x dx. So when we are finding the integral of sec, it gives us tan, just like when we are differentiating tan, we get sec, because integration and differentiation are just opposites of each other. So this will simply give us a 3 tan x, and then a constant of integration, and therefore this will just be negative 4 cos x, negative 5 sin x, plus 3 tan x, and then plus a c. So that is going to be the value for this one. But the integral of 4x squared plus 1, okay, 4x plus 5 to the power, let's say to the power 5 with respect to x. Now we're able to work out this one. Well, when we want to integrate this one, what we are going to do is, first I'm going to get my function 4x plus 5. The power, I'm going to add the 1, becomes power 6. And then divide that same 6, I'll multiply by the number which is in front of x here, that is a 4. and then just add the constant of integration. And so this is going to be 4x plus 5 to the power 6 divided by 6 times 4, that is 24, and then plus c. So that is going to be the integral for that one. Now at times we can be dealing with definite integrals. That means they've got limits. So say if they've asked us to evaluate the integral between the limits 2 and 1 of, let's say, 2x squared plus 1 dx. How can we work out this one? So this is going to be equal to, whenever we integrate, the integral symbol goes. And so when we integrate 2x squared, we're going to get 2x. We add the 1 to the power, it becomes power 3, and then divide by the same 3. And then plus, if we integrate 1, we simply get x. So the limits now becomes here 1, 2 there, 1 there. The upper limit is always on top and the lower limit down. So what happens here is we're going to write the definite integral between, the upper limit is pi over 4, the lower limit is 0, and we're talking of the integral of 2 cos x minus sin x dx. How can we work out this one? Well, this is going to be equal to, we are going to find the integral of cos. Now when we get to integrate cos, we are going to get sine, so that is going to be sine x. And when we get, so we have got negative sine. When we get to integrate negative sine, we are going to get positive cos. Already saw the table which we drew earlier. And now we're going to put our limits. We have got pi over 4 and also 0. As we saw earlier, when we are evaluating definite integrals, we don't put a constant c. That is only for indefinite integrals. And so this is going to become 2 sin, where there is x, now we're going to put pi over 4, and then plus cos pi over 4, and then we're going to subtract. We put the lower limit, that is going to be 2 sin 0, and then plus cos 0. So this is going to give us 2. Now the question is, what is sin of pi over 4? Well, pi over 4 is simply 45. The sine of 45 is 1 over root 2. The cosine of 45 is also 1 over root 2. And then minus. Now we have got 2. Sine of 0 is a 0. Cosine of 0 is a 1. So this is going to give us 2 over root 2 plus 1 over root 2, and then minus, we just have a minus 1. Now this one, I can also write it as root 2 over root 2, so that I just have the same fraction with the same denominator. And we know that root 2 over root 2 is simply a 1, so we are really not changing anything. Therefore, this is going to give us, in the denominator, we're going to have the root of 2, and then on top we're going to have 2 plus 1, which is a 3, and then minus square root of 2. So this is going to be the value. Thank you so much for having been present. Please be sure to subscribe and stay blessed.